Our next lesson is about representing exponential functions using exponential models. This is again week 5, day 3 of our subject in general mathematics. Now you may ask, where can we apply exponential functions particularly in real life situations? Actually, there are lots of applications regarding exponential functions, but the most common applications of exponential functions are in population growth, half-life of a substance, and of course, compound interest, which is common in banks and businesses. Let's start with exponential models and population growth. Suppose a quantity doubles every t units of time. If y sub 0 is the initial amount, then the quantity y after t units of time is given by this model. Y equals y sub 0 times 2 and then exponent of small letter t over big letter t. Y here is the quantity. Y sub 0 is the initial amount of that quantity. 2, it's because it doubles. We use 3 if in the problem it triples. Small letter t is the quantity after t units of time, while the big letter t is when a particular quantity doubles in that t units of time. So to better understand this model, let's apply it using the problem below. At t equals 0, there were initially 20 bacteria. Suppose that the bacteria doubles every 100 hours. Give an exponential model for the bacteria as a function of t. So now, let us consider the given data in our problem. At t equals 0, that is our initial time. Then, there were 20 bacteria. That's the initial number of the bacteria. That particular bacteria doubles every how many hours? 100 hours. So using the model that I have presented a while ago, the exponential model for the population growth of that particular bacteria is y equals 20. This is the initial number of the bacteria. Next, 2. It's because doubles. In our problem, the bacteria doubles every 100 hours. So, small letter t over 100. The big letter t is 100. So, our exponential model for this situation is y equals 20 times 2 to an exponent of t over 100. Next, exponential functions and half-life. If the half-life of a substance is t units, the big letter t, and y sub 0 is the amount of substance corresponding to t equals 0, small letter t, then the amount y of substance remaining after t units of time is given by y equals y sub 0 times 1/2 to the exponent of small letter t over big letter t. Why is it that we are already using 1/2? It's because we are now on exponential functions and half-life. Mao nang naatay 1/2. So kano saan man ta mo gamit sa small letter t and big letter t? The small letter t is the time after, while the big letter t is the half-life of a substance in t units of time. Kung half-life, if population growth, the population of that particular quantity on that particular time. So, manang mo gamit sa big letter t. The small letter t is used after t units of time. The hint is the word after. So, if na ay word nga after t units, kana siya nga number is used in small letter t. Let's apply it in our problem here. Suppose that the half-life of a certain radioactive substance is 10 days, and there are 10 grams initially. Determine the amount of substance remaining after 30 days and give an exponential model for the amount of remaining substance. To write the exponential model for this situation, we have to take note. This is already half-life. And then, take note of the given data. So we have half-life, 10 days, 10 grams initially. For our exponential model, these are the data needed. We have to write it this way, y equals 10. This is the initial number of the substance. And then 1/2. It's because half-life. And the half-life of that substance is 10 days. So it is to be substituted in the big letter T. So that's why we have here T over 10. Now, in the problem, there is also a given which is after 30 days. Where do we need to substitute that? That's in the small letter T. But first, ipangita man ang exponential model. So this is our exponential model. To determine the amount of substance remaining after 30 days, we use our exponential model. So we just substitute the small letter t with 30. So 30 over 10 is 3. Now, you need to get the cube of 1/2 first before you multiply it to 10. So you follow the rule PEMDAS. Parentheses, exponent, multiplication, division, addition, and subtraction. Multiplication and division is left to right. Addition and subtraction is also from left to right. So in this case, we need to get first the cube of 1/2, or 1/2 is to be raised to an exponent of 3. And 1/2 cube is 0.125, and then multiply it to 10, that is 1.25. Therefore, the amount of substance remaining after 30 days is 1.25 grams. Next application of exponential functions is compound interest. If a principal P is invested at an annual rate of R, compounded annually, then the amount after T years is given by A equals P times quantity 1 plus R raised to an exponent of T. A is the amount, P is the principal, R is the rate, and T is the time in terms of years. Example, Mrs. De La Cruz invested 100,000 in a company that offers 6% interest compounded annually. Define an exponential model for this situation. Next question, how much will this investment be worth at the end of 5 years? So, our given, we have 100,000, 6%. By the way, 100,000 is our principal, 6% is the rate. So for our exponential model, we have y or a equals 100,000 times 1 plus 0.06 raised to an exponent of t. So our 100,000 is there. Then 6% is equivalent to 0.06. We can simplify it further as y equals 100,000 times 1.06 to the power of t. This is our exponential model. The next question is the amount of the investment at the end of 5 years. Using our exponential model, we just have to substitute the small letter t with 5. 1.06 to the power of 5, you can check using your calculator, is 1.33822557.8. And then multiply it to 100,000, the result is 133,822.56. Therefore, the investment is worth 133,822.56. Here are some solved exercises for your reference. First, the half-life of a substance is 200 years. Give an exponential model for the situation, and how much will remain after 400 years if the initial amount was 90 grams. For the answer, we have y equals 90. This is the initial amount of that substance 90, and since this is half-life, we use 1/2. Then the small letter t over the big letter T, which is 200, since this is the half-life of the substance. The next question is to get the remaining substance after 400 years. 400 will be substituted to the small letter t, and if you will solve it, after 400 years, the remaining substance is 22.5 grams. You can check this one using your calculator. Next problem. At time t equals 0, 200 bacteria are in a petri dish, and this amount triples every 18 days. Give an exponential model for the situation. The exponential model for this problem is just y equals 200 times 3 raised to an exponent of t over 18. We use 3 because in the problem it is stated that the amount of the bacteria triples every 18 days. The next exercise is about compound interest. So for the model, we have y equals 15,000 times 1.058 raised to an exponent of t. And then after 10 years, the total worth of investment is 26,360 pesos and 15 centavos. And that's it. Have a great day.